Right, let us look at this new question here. Says evaluate the double integral k dx, where R is bounded by y is equals to 1 plus x squared and y is equals to 2x squared. So we are given parabolas. So we're given parabolas. So drawing them, I will start with the one with the turning point at the origin. Start with this one. Yes. And the next one is the turning point at 1. There is a turning point at 1 parabola. Right. So both of them are in this form. So there are points of intersection. We focus only on the points of intersection, right? So how can I get those points of intersection? What do you think? I need to equate these two. So I'm going to have a 2x squared is equals to 1 plus x squared. Simplifying this, I'm just going to have an x squared minus 1 is equals to 0. X is either minus 1 or x is either 1. Now when x here is equals to minus 1, you take this minus 1, you substitute it anywhere here in these two equations, I'm going to get 2. Now when x is equals to 1, again, I'm going to get 2 because the parabola is symmetrical. So your region of interest, it is this one. Let us go to the point of intersection and draw a line vertical, like that. Both of them, they do not enter this region. But when I draw a line horizontal, they do not enter this particular, they do not enter the region also. They do not enter the region also. The problem is that this y value here, because this is a parabola, we will only pick the external vertical thing. We are going to pick the vertical lines because we are sure that the region starts here and ends there. Now for y, because there is a curve still, we are not sure. That's why we will say a double integral of k dy dx. And then for x, I'm going to start from -1 to 1. And then for y, I'm just going to draw a vertical line from bottom to top. Anywhere in your graph, bottom to top. Anywhere in your graph, bottom to top. You'll see that your bottom graph, it is 2x squared. And your top graph is 1 plus x squared. And then now you can integrate. Right, you can integrate. Also make sure that you are trying to understand that concept there. It's quite handy to know that concept. It's very, very handy to know that particular concept. Right, the next one, it's not that simple, but make sure you understand where I'm going with it. I'm saving others for the changing the order of integration. Right. Evaluate the double integral R2 times k dA. Now just know that this k here is just a constant. It's the same as this one. Comma, R is bounded by y is equals to x is equals to y minus 6 and x is equals to x is equals to y minus 2 squared minus 2, like that. So that is your region, your boundary conditions. Now let us draw that region. Drawing that region, it's not something that you are guaranteed to know. That is the thing about these things. But you can actually do them using a calculator though. That 1, that x. And then there's a straight line. There's a straight line. And there is a parabola. Nope. The parabola is not a V. No. Curve it. No, I'm not doing that shit. I'm not doing it in that form. Yes, better. But I'm moving it upwards. Yes. Right. That like that. The graph like that. Now, you are going to confirm the points of intersection. I got 2 and 4. And I got 7 and negative 1. Right. Now this is a region that you're thinking about. Now, let us draw the lines. If you draw a horizontal line here, does it enter this region? Does it enter? No. But when you draw a vertical line here, that vertical line there enter the region. There is a problem. If we draw a horizontal line, a vertical line, sorry, it does not enter a region. If we draw a vertical line, a horizontal line, it does not enter. But this one, that vertical line, when you drew the region, when you draw it, it entered the region. It means that for a double integral of 2k dd, I am no longer going to end with dx because there was a vertical line there, so I'm going to end with dy dx. Now your dy, your small value of y there, it's going to be -1, and your maximum value of y there, it's going to be 4. And then to get your x value for the first graph, you just draw a line horizontal, left to right. left to right. Now, when you do the left to right thing, what is your graph, your first graph in terms of x? It is that parabola, which is y minus 2 squared minus 2. And then that graph in terms of x was minus y plus 6. Right? So this is a particular region that I was concerned about. Which you need to know how to draw this particular region. And this is the only way you can do it. Please try to figure out how did I got the 7 and -1 and the 2 and the 4. Thank you.